Problem 3, we got a new function to look at. We'll review our absolute value function. All right, we've talked about, again, the squaring function y equals x squared. We've talked about square root. Let's look at absolute value, another function that we run into a lot, a common function to deal with. With that said, I'm going to do this one a little differently just to show you a different approach with easily sketching your graphs. I'm going to use a table of points to help me. But when I see this problem in problem 3, the first thing I think of is, where is this graph coming from? What is its parent function? And you can see this is dealing with our absolute value function, right? Now, our absolute value function is a V-shaped graph, and I'm going to build that right now using a table of points. So you can see down here, before we talk about transformations with f of x, you can see there's some changes from absolute value of x. Let's go ahead and build the parent model. So we could do that easily. We knew nothing about the graph. We could build a table of points using different domain values, different x values. For example, we could let x be 0. We know that y equals absolute value of x, y equals absolute value of 0 is 0. So 0, 0, right, is a point on the graph of absolute value of x. So we could go ahead and plot that point. And let's do a couple others. We could let x be 1, for example. Y equal absolute value of 1 equal 1. So getting some easy points to plot. We know the graph absolute value of x will pass through 1, 1. And let's do a negative value. We could let y equal, or let x equal negative 1, which means y equals absolute value negative 1. And that also equals 1. So just real quick, reviewing our absolute value definition. Remember, absolute value is a distance from 0 on the number line. So that's why the absolute value negative 1 is 1 unit. It's 1 unit from 0. So as you plot that point, you get negative 1, 1 over here. Now graphing that, I'll go ahead and graph it. This is the graph of this V-shaped function, the absolute value of x. This is the parent function for problem 3. All right, well, let's go talk about now the changes that take place with the function f of x. And we can go ahead and circle those if you like. There's 3 changes that take place. One of them being the negative out in front. Right, and with the negative out in front, it's going to cause a reflection. All right, we also have this plus 1 in here. Now, it might help you to go ahead and rewrite that since with the x. I've talked about this earlier. I'll rewrite x with a minus sign. I'm always writing standard form. Now, a sign attached to x. X minus negative 1 is 2x plus 1. And hopefully that'll help you with the horizontal shift property in a second. So it causes our graph to shift horizontally. And then this plus 4 on the outside is going to cause a vertical shift. So that's what it has to do, list the transformations. So let's go ahead and take care of the negative, for example. Well, the negative causes my graph to reflect. All right, we're going to reflect this time the x-axis. All right. We're going to reflect the x-axis, which means every ordered pair, x, y, you will find the ordered pair of x negative y on your graph. Okay? Why? Because you're reflecting the x. Every point, for example, if 2, 3 was on the graph, right? 2, negative 3 was on the graph. So if our absolute value function, 1, 1's on the graph, we know 1, negative 1's on the graph. Negative 1, 1's on the graph, negative 1, negative 1's on the graph. We're multiplying every y coordinate by a negative. We're multiplying our function by a negative that reflects the x-axis. Now, if the negative's inside with the x directly affecting our domain variable, right, it flips the y-axis. You're multiplying each x coordinate by a negative. So if we would have a 1, 1, go to negative 1, 1, right? Or negative 1, 1, go to 1, 1, vice versa. So that's a review of our reflection property. Remember, multiplying by a negative causes a reflection. Let's go ahead and list the other 2 changes. Now that x plus 1, that plus 1 with x, which I rewrote as a minus negative 1. And we can go ahead and write that down here. With that said, that causes a horizontal shift. So we're moving our graph horizontally left to right. Now we're subtracting a negative 1. We're going to go left 1 unit. All right, which means what? every ordered pair. Now we've moved xy to x negative y. Now we're going to have the point of x minus 1 negative y. We're going to subtract 1 from every x coordinate. Left 1, right? Subtract 1, right? Showing that translation. And then our final change, I'll bring it down here. We got a plus 4. So that's going to move our graph vertically up 4 units. So if you think about your ordered pair, now we've got our x minus 1 after moving it left 1 unit. We got the negative y reflecting the x-axis. And then we got to add 4 to that to move it up 4 units to get negative y plus 4. So there's our new right point, our translation. So as we build our ordered pairs, let's go over here and we'll build a table now of points. So our x-coordinate, all right, as we're translating this graph, where do these points move to? So the x-coordinate is going to be x minus 1, and the y-coordinate is going to be negative y plus 4. So if you take, for example, x equals 0, right? You have 0 minus 1, which is negative 1, right? And if you go to the y-coordinate, right? You're looking at the y-coordinate, what are you going to get with it? You're going to plug in, right? 0 into your function. So you plug in your 0 to get to that point. All right? So again, y, which was 0 over here. So you got that y-coordinate. So it's going to be, what, negative 0 plus 4, which is 4. You're plugging in that point there, negative 1. So that's where it translates to, right? You're going to be looking at the point, negative 1, 4 on our graph. So again, we could go plot that point. So again, we're plugging in these coordinates. We're translating them. So again, we'll plug it in the x and the y. Where do they translate to? Let's go ahead and plot that. Negative 1, 4. Left 1, up 4. And plot this point. All right, let's take our point here. So now we're looking at x equal 1. Well, let's translate it. So with that, we got 1, right, minus 1, which is negative 2. And then our y-coordinate, which was at 1. So we plug that in. We get negative 1, right, plus 4, which simplifies to 3. So that means we're going to pass through the point, what, negative 2, 3. So we could plot negative 2, 3. So negative left 2, up 3, right here. Here's negative 2, 3 on our graph, right? Passes right through that ordered pair. And I'll go ahead and label that point. And we had one other point, right, that we looked at, and that's at negative 1. Well, let's go plug that in. So negative 1 minus 1, right? And somebody check me. Back on this last one. Got a mistake here. We need to correct that. What is 1 minus 1? I put negative 2 in the previous example. Well, 1 minus 1 is 0. So if you're looking at that, we had a new x-coordinate value of 0 and a y-coordinate value of 3. So it went through 0, 3, didn't it? So be careful with that, because I'm getting ready to see this one. This is what happens. So as we plugged in the negative 1 here, right, well, we get negative 2. There's that negative 2 for us. All right. So again, I need to correct that last one. Had a little arithmetic here. Double check your work. All right. Again, this is that point 0, 3 we found the previous step. Now go to the y-coordinate. So our y-coordinate, which was also positive 1. So as we plug that in, I got negative 1 plus 4. So I get 3 again. So now I get that ordered pair of negative 3. So that is on there. So you see that translated over. So again, I'm taking these points, right? I'm plugging it in over here to get to these new values, right? And you see your x-coordinates plugged in, right? As I plug those in to get to the new x-coordinates. Now, as I connect these points, I have my graph up here. And you can see this graph's now turned upside down. You got that upside down V-shaped, right? But it has been shifted left 1 unit and up 4. But there's our function. Let's go ahead and write that down here on this graph. Let's go ahead and put f of x here. So f of x equal to negative absolute value of x plus 1 plus 4. All right. Let's move on to another one. So again, a little different approach, using a table of points. Maybe you like that approach better and just walk it off step by step like I've been doing in my graphs. Let's do the same thing in this one. As I look at my function here in problem 4, I've got f of x, and this should be equal to, a little notation error here, but negative 1/2 x minus 1 cubed. Now, first thing I think of is, what is my parent function? What's the graph I'm transforming? Y equal x cubed, right, in my graph. So that's the parent function in this one. So we'll be building a table of points to help us with that. So if you want, just go ahead and write that down. So what is our ordered pairs? So again, we're trying to build in our parent graph. We're talking about y equal x cubed. Well, let's find a few points. So we could let x be, for example, 0, right? If we let x be 0, what's y going to be? So y is equal to 0 cubed, which is 0. So that gives us the ordered pair of 0, 0. So we could plot 0, 0. So we know the y equal x cubed graph pass through the point 0, 0. Let's find a couple other points. Let's let x be 1. All right. Well, y equal 1 cubed. 1 cubed is 1. 1 times 1 times 1. So we get 1. So we know this graph also passes through the point 1, 1. I'm going to plot 1, 1. And I'm going to do a negative value. Let's do negative 1. Just a few quick points. Something easy to plot. Make it easy to graph. Negative 1 cubed is negative 1. Negative 1 times negative 1, negative 1 gives us a negative 1. So we pass through the point negative 1, negative 1. We'll plot that point right here. Right? And we could find as many as we need, right, in our graph, but this will give you a quick sketch of this function. So this is our y equal x cubed parent model. So at least label a few points, right, to give some detail to your graph. Now I want to list the transformations. All right, so let's take a look again at what changes are taking place. So as we list the transformations, all right, we've got, in this problem, 3 changes taking place. And we'll walk through each of these transformations. All right, first one I'm going to take care of is this 1/2 right here. All right, this 1/2, let's go ahead and write it down here. This 1/2 causes a vertical shrink or compression, however you want to call it. But I'm going to go ahead and write it down here. So a vertical, so we're multiplying our function by a constant. So we've mentioned that before, we multiply by a constant. Now, with that said, we're multiplying our function by a number less than 1. So this is a vertical compression, right? Or shrink, however you want to refer to it, by a factor of 1/2. So that means we're going to multiply every y coordinate by a factor of 1/2. So as we take our ordered pairs, for example, x, y, right, we're going to be producing the new ordered pair of x 1/2 y. That'll take care of that first change. All right. And now let's go ahead and look at the negative that's out in front. And we'll change it to a different color as we look at the negative. Let's change it to red. So what does this negative do? So we know the negative, I'll bring it down here. We've talked about negative today, causes reflections. So we're going to reflect. So after we compress or shrink our graph by a factor of 1/2, all right, we're then going to reflect our graph. Now, since we're multiplying the function by a negative, we're going to reflect the x-axis, right? So again, we're not multiplying the domain variable by a negative. We do reflect the y-axis, not multiplying x. We're multiplying the function f of x, right, by a negative. So we'll reflect the x-axis. So now, with that said, we're going to have a negative out in front. So let's write that down here. So what is our ordered pair now going to look like? It'll be x negative 1/2 y, right? I'm going to play our y coordinate by negative. And then we go to our last change. All right, if you want, we can put that a different color. Let's put that here in green. All right, with that, what is my last change? What's the last different thing we see, which is a -1 from x? I'm going to bring that down here and write down my transformation. So that -1, now we're inside, right? We're directly affecting x. Now, since we're subtracting a +1, this is a horizontal shift right. So we subtract a -1, we go left. We're subtracting a 1, +1. We're going to shift right 1 unit. So that implies our ordered pairs. That means we're affecting the x-coordinate by adding a 1 to it. Right? So there's our ordered pairs. We go to our new table. Right? As we build our table of points, right, we can go put that right here beneath it. So if you want, we'll write it right here beside it. So again, we're trying to graph our function. So f of x equal to negative 1/2 x. I'm sorry, that 1/2's out in front. Let's go ahead and correct that. All right, so we got negative 1/2, and then the x minus 1 cubed. So building the table. So we look at our x coordinates, right, in our new table. We're going to have a x plus 1 for the x coordinates. Right? And in our y coordinates, we're going to have a negative 1/2 y. So let's show those translations right here beside it. So as we take, for example, x equals 0, so we're going to have 0 plus 1, which is 1. So out went x, right? In went 0. That's what x was on the graph, y equals cubed. So it gives me x coordinate of 1. And in our y coordinate, we're going to do the same thing. Y is 0, so negative 1/2 of 0. Of course, anytime 0 is still 0. So it's still going to be passing through the point, right? 0, 0. As we're moving it there, again, our graph, looking at our horizontal shift, right, 1 unit. Y coordinate be 0. So we got a new point of 1, 0. Let's go ahead and plot that point. So 1, 0, right over here, where our graph passes through. Let's go ahead and look at the next point. Let's go ahead and look at x equal 1. So as we translate that, so out comes x, in comes 1. 1 plus 1 is 2. And then with the y coordinate, which it was also 1, let's plug that in. I got negative 1/2 of y, negative 1/2 of 1, which is negative 1/2. So I have my point here of what? 2 negative 1/2. So I need to plot 2 negative 1/2. So let's go over here and plot that. I'm going to erase 0, 0 here so we can see that point here. So we go to 2. We're going down, right, 1/2 unit. Here's that ordered pair of 2 negative 1/2. And then let's go to negative 1. As we look at negative 1, what's negative 1 plus 1? That's 0. So plugging that in, right? Go ahead and change this here. So yeah, negative 1 plus 1 gives the 0. And then our y coordinate. Well, our y coordinate was negative 1, so we got negative 1/2 of negative 1, which is positive 1/2. So our new point will be the point 0, 1/2. So let's plot 0, 1/2. So 0.5 right here on the y-axis, our y-intercept point for our graph. We can plot that in here. But here's our graph now. As we shrunk or compressed our graph vertically, right? We've reflected across the x-axis. We'll go ahead and connect these. There's our graph. So you can see our graph there transformed as we go through that. Just listing a few points, right? Showing those transformations with our graph. And that one's been, again, shrunk vertically with that. All right, so that's good review. Looking at our transformations. Now let's look at our last example in here. I'll go ahead and finish this off. We have a couple transformations. Now this time they give us our function by the graph right over here to the side. So instead of giving us the equation, they show us the graph of the function. And they want us to graph in y equal f of negative 1/3 x. So list the transformations that take place. So as we're looking at this one, let's go ahead, for example, let's take care of this 1/3 that's in here. Well, that 1/3, since we're multiplying domain variable by a constant, all right, this is where we have a horizontal stretch. Now you would think 1/3, right, it would be a compression because it's less than 1. But it's opposite of what you think when you're looking at horizontal stretches and compressions. Right, whenever it's less than 1, you've got a stretch. And how do you stretch it? By a factor of 1 over 1/3. 1 over a. It's always 1 divided by, we go value here of a. 1 over a when you're doing horizontal. All right, stretch or shrink for that matter. So 1 over 1/3. Well, 1 over 1/3 is 1 times 3 over 1 or 3. So you multiply by a factor of 3. So you multiply a factor of 3 here. So with that said, we would have every ordered pair, and let's write it down. So every ordered pair xy, right, we would have a new ordered pair of 3xy as we stretch our graph by a factor of 3. And then we have the negative. All right, let's go ahead and look at the negative out in front. We know multiplying the domain variable by a negative, that reflects the y-axis. So that takes every ordered pair xy, multiplies the x-coordinate by a negative. So that implies our ordered pair, right, would actually be a negative 3xy. So you can take your points. So let's go ahead and show that. So if you look at your graph over here of f of x, right, and we can write down here our table. Right, so our table points that we were given just based off the graph above, right? We were given the ordered pair negative 2, 0, right? Negative 2 zeros on the graph. We were given the ordered pair, and I'll plot them over here. We were given the ordered pair here of negative 1, 3, right? So negative 1, 3 is on this graph. And let's go back to it. We were given the ordered pair of 1, 2. All right, 1, 2 is on this graph. So as you show your translations, let's take now y equal f of negative 1/3 x. Put that beside it. All right, so as we build our table now of values, we've got our x-coordinate, right, negative 3x. And then our y-coordinate, which remained unchanged in this example. Let's show that table. So negative 2, 0, for example. So negative 2, right, that would be negative 3 times negative 2, which is a positive 6. And as I go to the y-coordinate again is 0. So that would give you the point of 6, 0, right, on your graph. So we can go ahead and plot 6, 0. So there's 6, 0. Now let's go to our next point. So negative 1. So we show its translation. So x-coordinate is negative 1. So we got negative 3 times negative 1, which is 3. And then, of course, our y-coordinate remains unchanged, which is 3. So we have the ordered pair of 3, 3 on this graph. So we can go ahead and plot 3, 3, write 3. up 3, 3 3's on this graph, right? And in our last point that we can translate, we'll show, let's plug in 1 for x. So we got -3 times 1, which is -3. And our y coordinate, we got 2. So -3, 2, right, is on this graph. So left 3, up 2 units, plot that point. And now we can connect, right? We can connect these points to show our graph of this function. So there's the graph of y equal f of -1/3 x. So in blue, x. And again, in black, right, you had the graph of f of x. All right, so again, review. Now that one showed a new property. We had not seen a horizontal stretch or compression or shrink. So real quickly, now we stretch because the coefficient of x is less than 1. Because you're multiplying by a factor of 1 over that coefficient, 1 over a. And then if the number is greater than 1, so maybe you'd had 3x or 2x or 4x, right, for your function. That would be a compression by a factor of 1 over 3 or 1 over 2, 1 over 4. So you'd be actually compressing or shrinking your graph horizontally. So you're affecting those x coordinates by that factor, 1 over a. So again, 1 over 1/3, which simplified to 3, right? 1 over 1/3 is 3. So we had that 3x, right, in our example, where that 3 came from. Multiplying that by that factor of 3, 3x. All right, and then again, the negative. Again, reflecting the y-axis. That's where that negative comes into play. Multiplying by a negative. All right, so I hope that helps you with transformation properties. Those are some good examples, and we looked at some different parent functions in our examples. Different approaches where we had to build the equation, or we had to take the equation, use the transformations to sketch it, or where they just give us the graph of function and we translate it like this last one. Right, so we'll stop there and continue it a little bit.